Hello, welcome back. In this video, we're going to talk about a few advanced operators that exist in the Java programming language. We have some beyond the basic arithmetic and equals assignment operator. We have some operators called the relational operator, where we compare the relationship between two variables or expressions. These are usually the greater than sign, the less than, the greater than relationship, the less than relationship, the greater than equal, the less than equal to relationship, and the greater than equal to relationship. We usually use these relational operators to validate some assumption. For example, if you have expression which says if value of variable a is greater than 8, then execute a code block. Similarly, we can use less than equal to, greater than equal to, and for doing relationships and comparing relationships between variables or expressions. Another operator, which is not exactly an operator in the classical sense, but is the conditional operator, the question mark followed by colon sign. It's essentially a conditional operator is essentially the same as if-then statement. If expression 1 then do expression 2, else do expression 3. Here, by doing this conditional operator, if you see over here, what we're doing is that we're testing expression 1. We can say if a equals 1, and if this expression is true, then we'll execute expression 2, whatever that is. If it is false, then we'll execute expression 3. So the conditional operator is a short form of mechanism to do an if-then-else statement in a single line. Hence, the conditional operator. Another class of operators are unary operators. Unary operators are operators which require only one parameter. Usually, the addition operator is a binary operator. It requires one operand and the second operand to do the addition operation. On the other hand, the unary operators are plus, minus, not, plus plus, minus minus. What's unique about these unary operators is that it needs only one operand. So plus b, if there is a variable called b, this just indicates this is a positive variable. Minus b indicates this is a negative variable. Not b, if b is a boolean, or let's see, not c, and let's assume c is a boolean, c equals true, then not c will essentially equate to false. It reverses the boolean value. And plus plus is the incrementer, and minus minus is the decrementer. And these are all unary operators because they only need one operand instead of two operands. So that's for as far as unary operators go. The next thing, set of operators are somewhat special and somewhat rarely used, but it's nonetheless it's good to know, are bitwise and bit shift operators. Essentially, in a computer, every integer or every integral value or any value is stored, be it int, double, float. It's stored in bits on the physical hardware system. So bitwise operators let you perform operations with these bits. Say variable a is 1 byte, and therefore it contains 1 byte equals 8 bits. So therefore variable a will have 1, 2, 3, 4, 5, 6, 7, 8. These are 8 bits. The value of every bit can be 0 or 1. So a bitwise operator basically does and, or, and such other exclusive or operations on the bits. For example, if we have byte A equals to 1, 1, 3, 4, 5, 6, 7, 8, and B equals to 0, 0, 0, 0. There you go. And now if we do A and B, the result will be, it will do a bitwise AND of these two bits, 1 and 0, which is 0. Similarly, of the next two bits, 0, and hence this whole thing is going to be 0. This is where is used very often for bit level manipulation. The second type of bit operators that deal with bits is bit shifting. So you have these 8 bits, you can shift them to the right or shift them to the left. Let's start a clean slate. So you have 0, 0. You have 8 bits here. So this is right shift operator and this is left shift operator. The right shift will shift all the bits to one position to the right, and this will drop off. Similarly, if we use left shift operator, this one would have dropped off. And that's what we do with bit shifting. Which changes the value, which for a lot of calculation, which can be very efficient. Again, something not used very often, but something good to know, and you should revise it if you have to use bit shifting for some complex arithmetic operations, for which you need a lot of efficiency. And that's it for advanced operators.